In the first part of 5.5, we're going to look at graphs of relations and functions. And just to recall some definitions, a relation associates the elements of one set with the elements of another set. A function is a special type of relation where each element in the domain is associated with exactly one element in the range. Domain is the set of values of our independent variable, and those are the x values of a graph. A range is a set of values of the dependent variable, and those are the y values of a graph. If we take a look at the arrow diagram below, and we were looking which arrow diagram was a function, hopefully you'll realize that this is the function because every element of the domain is going to one and only one element in the range. Now, when we look at graphs of relations, we can tell whether or not a graph of a relation is a function by using what's called the vertical line test. If we draw a vertical line and it crosses through more than one point, then that graph is not a function. If you look at the second graph, no matter where I draw a vertical line, it's only going to touch one point. This would represent a function. So the vertical line test, again, is used to determine whether or not a relation is a function. So if we take a look at these first two, again, this one's quite obvious. If I was to draw a vertical line right there, it would go through many points. So this is not a function. And no matter where I draw a vertical line on this graph, it would only touch one point. So this one is a function. Okay, I encourage you to pause the video and try these two. Okay, if we take a look at these two, clearly we can see that if I draw a vertical line at 160, it passes more than one point, or through more than one point. This is not a function. This one would be a function because no matter where I draw my vertical line on this graph, it would only cross one point. Now, we use a vertical line test, as we found out, to determine whether the graph of a relation is a function. Once we've found out that it is a function, we can use the horizontal line test to determine if the function is a one-to-one function or a many-to-one function. If a horizontal line crosses the graph more than once, it's a many-to-one function. If the horizontal line crosses the line only once, it would be considered a one-to-one function. So in this next set of examples, we're asked to identify which of the following are functions. And once we know they're functions, we're supposed to use a horizontal line test to determine whether they're one-to-one or many-to-one. So clearly, this is not a function, this is not a function, this is not a function. So those three are not functions. The other three are, because if I draw a vertical line anywhere, it only crosses the graph once. So for a horizontal line test, it crosses the graph twice. This would be considered many-to-one. So too with this one, and so too with this one. So all three of these functions are many-to-one functions. Now, as we said earlier, the domain is a set of x values of our graph. The range is the set of y values. Now, if a graph has a closed dot, that means the point is included in the domain or the range. An open dot means the point is not included. And if a graph has no dot at the end, our textbook interprets that to mean the graph goes on forever and ever. I like to put an arrowhead on the end to indicate that it goes on forever and ever. So if we take a look at this graph here, I'm going to put a little arrowhead here. We want to identify the domain and range of each of these graphs. So for my domain, I look at my x values, and my first x value on the right, the furthest it goes is -3. And as this graph continues on, it will go further and further to the left. So all of my x values will be less than or equal to 3. For my range, my lowest y value is -1, and all other y values are bigger than -1. So I would write it as y is greater than or equal to -1. In the second example, my x values go from -2 to 2. So for my domain, I'm going to write it as 1 inequality. And I'll write -2 is less than or equal to x is less than or equal to 2, which really means x falls between -2 and 2. And it includes -2 and 2 because there are solid dots there. For my range, I look at my y values. Well, my lowest y value is 0, and the highest y value is 2. So similarly, 0 is less than or equal to y is less than or equal to 2. Okay, I encourage you to pause this video and give these two a try. Now again, remember this should have an arrowhead for my liking, indicating the graph goes forever and ever to the left. Okay, hopefully you got a chance to try this one. And the domain for this function, again, I start the furthest to the right is 5. Everything else is smaller than 5. So x is less than or equal to 5. For the range, the highest y value is 2. Everything else is lower. So y is less than or equal to 2. For the one on the right, my domain is going from -3 to +5. So it's -3 is less than or equal to x is less than or equal to 5. And my range is going from +3 all the way up to and including 7. All right, so there is your assignment for today. There's a couple of questions you can think about, and we can discuss them in class the next day. Again, if you have any questions, the answers are on the website. And there's also a handout I'm going to give to you for helping you identify range and domain off of graphs. All right, good luck.